Note card number 12, horizontal tangent lines. Problem number 1. We're going to find the points, if there are any, where the function has a zero slope. That's what horizontal tangent line means. The derivative is 0. Then we're going to write the equations for these tangent lines. All right, well, if there are horizontal tangent lines, then we know the equation is going to be y equals whatever the y coordinate is of the point of the horizontal tangent. So that should be pretty easy. All right, if we're going to have a zero slope, let's find the derivative and set it equal to 0. Okay, and then over here we're going to have to factor. There's not a GCF, so we're just going to go straight into a binomial times a binomial. And through a little trial and error, we should be able to factor it into 3x minus 5 and x plus 3. Set each factor equal to 0, and from here we can see that we're going to have x equals 5/3 and x equals -3. Totally acceptable to go from this line to this line. That's something we should be able to do. All right. Now what we have to do is get the points. So we have two different x's. Let's just one at a time plug them back into the original function to get the y's that belong with those inputs. Okay, so here's where I would use a calculator because this number is ugly. Too tedious of calculations here. So this evaluation gives this decimal. Evaluating the original function to get the y at -3 gives 50. All right, so it says find the points. This format is okay, but I'm sure they'd probably prefer it in ordered paired form. All right, and one final thing to do is to write the equation for these tangent lines. Well, the tangent lines are going to be horizontal lines, and the horizontal lines are just going to be y equals for each of the y coordinates. Example 2. Okay, let's figure out where this graph has any horizontal tangent lines. I might encourage you guys to type this into Y1, see what the graph looks like. Just kind of eyeball where you think you're going to have a zero slope. And I think if you did that for this problem, you would probably notice that this graph is never going to have a zero slope. Oh, I meant to pull this out of the denominator. So this is going to be 2t to the -3. And not that I need the over 1. I'm getting it ready for differentiation. I'm going to set the derivative, that was the derivative, equal to 0. So I'll put this over 1 and do cross products. Well, this is going to be 0. 0 equals -6. That's a false statement. So all that tells us is that there's no x that's going to make this 0 happen over here. So we don't have a horizontal tangent. So you should just report no horizontal tangents. Example 3. Or I guess it's number 2. All right, so h is a function, and this is the derivative. We're going to find the x values for which the graph of h has a horizontal tangent. So that's going to be where h prime of x equals 0. And what a little gift they gave us here. They went ahead and found the derivative. So we're going to set that equal to 0. Do cross multiply. I can solve this. I'm going to get two solutions, the positive and negative square root of 2. These are the two x coordinates of where the graph has horizontal tangents. Looking back at the question, I guess that's all it asked me to do. It didn't ask me to find the point. And I couldn't anyway because they never gave me h. So I have nothing to plug these x values back into. I guess they could have asked me if I had any mins or maxes occurring at these zero slopes, and I could have done a number line. But we're done. Let's go to the next one, number 3. All right, 3 is the same thing as number 2. They went ahead and gave you the derivative. So actually, this is not too much of a calculus question. It's more, can you solve this equation for 0? So it'd be good to write that this is what you're doing. You're setting the derivative they give you equal to 0. The obvious thing here would be to move 2 sine x over, divide by 2. You can trade sides if you want to, but you're just finding the angles whose y-coordinates are positive square root of 3 over 2 on this defined interval. So where is x going to fall between 0 and 2 pi? I'm sorry, what angle has a y-coordinate of square root of 3 over 2 on this interval? Well, let's think about our unit circle. That's going to occur at pi over 3 and 2 pi over 3. So we have 2 pi over 3. 2 solutions from the unit circle. These are 2 locations where you have a 0 slope. Again, we don't know if that's a max, min, or neither. We can't. Well, I guess we could figure it out. We could do an f prime number line, but we're not asked. Okay, so we're going to move on. All right, let's look at note card number 13. All right, so for this one, we're looking for locations of vertical tangents. Vertical tangents have a 0 slope. Have a 0 in the denominator of the derivative. All right, so same process here. Find the points where the function has vertical tangent lines, then write the equations for those tangent lines. Now let's find the derivative and set it equal to an undefined situation. Let's see. First of all, I'm going to do a little work here. 3 minus x to the 1/3. Let's find the derivative. Derivative of constant, 0. Power rule here, so negative 1/3 x to the negative 2/3. Okay, and I don't want to set this derivative equal to 0. I want to set it equal to 1 over 0. So let me do a little cleanup first. 1 over 3, and this is going to be x squared cube root. All right, so let's take that derivative. And set it equal to 1 over 0. And cross multiply. Divide a 3 on both sides. Cube both sides. And find the square root. That's the x-coordinate at which I have a vertical tangent. So let me find the y-coordinate. They did give me a regular equation. So wherever I have x, I'm going to replace it with 0. So my y-coordinate is 3. So to answer the question, what's the point? Well, the point's 0, 3. What's the equation for this vertical tangent line? Well, a vertical line would be written in the form x equals. So we just take the y-coordinate. How about I lied? X equals 0. We're looking for a vertical tangent line, and the equation of our vertical tangent line would be x equals. All right, let's look at B. Using the chain rule, we're going to differentiate. Derivative of the inside is negative 2x. Let me clean this derivative up before I set it equal to 1 over 0. Now what you can do is you can reach across here, and this 2 is going to divide with this 2 right here, leaving a negative. So my answer is going to be a fraction. I'll have a negative x on top, and I'll have the square root of 4 minus x squared in the denominator. Set your derivative equal to 1 over 0, undefined. If you cross multiply, should be a minus. So where is 0 equal to that expression? Hang on. Square both sides. Add an x squared to the other side. So we know our two solutions are going to be positive, negative 2. Okay. So let's evaluate what is f at 2, the regular graph at 2. When you plug 2 in, you're going to get 0. What's f evaluated at negative 2? Well, plug negative 2 in and you'll see that the output is also 0. So these are the 2 points where you have vertical tangents. But it also asked us to write the equation for these tangent lines, so that would be x equals 2 and x equals negative 2. Okay. All right, let's look at example 2. All right, the reason there's so much space below problem 2 is that it takes all that space. All right, so the thinking's the same right here. We're going to consider this function. We're going to find just the x-coordinate where the tangent line is vertical. So find the derivative and then set it equal to 1 over 0 and solve from there. All right, this requires implicit differentiation. Product rule here, product rule here. Right. So for this first term, it's the product rule. First times the derivative of the second with respect to x. 2y dy dx. Plus the second factor at y squared times the derivative of the first, which is just 1. Okay, let's move to the second term, product rule as well. The first factor times the derivative of the second, plus the second factor y times the derivative of x cubed. With respect to x is just 3x squared. Okay, we're going to close the parenthesis, move across the equal sign, the derivative of 6 is 0. So I'm going to clean this up right here. I'm going to distribute the negative sign. I'm going to gather up the dy dx terms and factor out dy dx. So that would be in this term and in this term. So quantity 2xy minus x cubed. And I still have plus y squared and minus 3x squared y. Both those terms need to go to the other side of the equation. Then we're going to factor out the common factor. Okay, so in a reminder self, after all that work, what we're finding is we're finding the x-coordinate of the point where we have a vertical tangent line. So what we need to do is set this derivative equal to undefined. And so you can go through all of this, but maybe some of you guys have seen already that it's really where the denominator equals 0. We'll go through the cross products. Okay, now this is in terms of x and y, so we do have a slight problem here. So what we need to do is maybe factor out x, and we're left with 2y minus x squared. So either x is 0 or 2y minus x squared is 0. So pause and think about x being 0 and go back to the original problem. If you plug in 0 for x everywhere you see x, you're going to get that 0 equals 6. Well, of course, that's a false statement. So what that tells us is that x equals 0 is an extraneous extra solution. Okay, so what do we do with this thing? Well, I'm going to just go ahead and solve it for x squared. So I'll have 2y equals x squared. And then what I have to do is go back to the original equation and either put in x squared is 2y, or maybe solve this for y, divide both sides by 2. We have some choices here. Okay, in that case, y would be equal to a half x squared, or x squared over 2. Okay, now connecting back to the original equation, everywhere you see y, you're going to replace y with this. Okay, so your equation, your original equation is going to be in terms of x's only, and you could solve from there. Okay, so at this point, I'm just going to show what I have, and you guys can see what the answer is, and know that those are the steps that I did perform. I'm picking up. There it is. Okay.
I want to see how in the making. You can't like see.
No.
Okay.
Just here.
Right.
All right. So I think we were right here where we factored out an x. We realized that x equals 0 was extraneous. And then how we had to tackle this factor right here is we set it equal to 0. Okay, we solved it for y. We ended up here. And then my little arrows here are suggesting that we take the original equation, and everywhere you see y, replace it with a half x squared. And that's what I did right here. I was just doing a lot of algebra. And then I brought us back up here. I had to get a common denominator. And it ended up being negative x to the 5th over 4 equals 6. Okay, I did cross multiply. I can take the 5th root or an odd root of a negative number, and we ended up with the x coordinate of the 5th root of negative 24. And as requested by the problem, all we're asked to do is find the x coordinate anyway, so at this point we're done. So just a review of finding horizontal tangents and vertical tangents. Yeah, I told